Most of the time when you do a randomized experiment, say a drug trial, you're going to assign some people to get the drug and some people to not get the drug. Well, the people who are in the treatment group, who you give them the drug, they might not take it. That's called noncompliance. Which happens when people don't actually get treatment when they're supposed to, okay? Or conversely, when somehow people in the control group obtain the real drug and start taking it. That's noncompliance. Now, there are 4 ways of dealing with noncompliance. The first is called intention to treat analysis. And the idea here is to redefine the treatment variable that we care about, and then just pretend that's the variable we cared about all along. Okay, and what I mean is, we initially wanted to know the effect of taking a drug on some outcome, but the problem is people in our treatment group weren't taking the drug, or some of them weren't. So what we're going to do is say, actually our treatment of interest is whether we gave people the option of taking a drug. And with this redefinition, noncompliance is impossible by definition, because we choose whether to give somebody an option or not them. So with this new definition, we can analyze the experiment just by comparing the outcomes, the average outcomes in the treatment group with the average outcomes in the control group, forgetting about the fact that some people in the treatment group might not actually be getting treatment, okay? And that comparison is going to give us the causal effect of being given the option of receiving treatment, okay? More specifically, it'll give us the average treatment effect. So for example, in the Oregon Health experiment, some people were given the option of enrolling in Medicaid. Not everybody did, but some people were given the option. What we're going to do is just compare everyone in the treatment group, those who were given the option, with everyone in the control group, those who weren't given the option, and that's going to give us the average treatment effect for being given the option to enroll in Medicaid, okay, on whatever outcome of interest, cholesterol, blood pressure, etc. Second approach for dealing with noncompliance is instrumental variables analysis. And the benefit of this is that it's going to let us get the true effect of having Medicaid versus not, as opposed to just the option of enrolling into Medicaid. The downside is it's not going to let us learn the average treatment effect, okay? It's not going to let us learn the average unit causal effects over the whole population. Instead, we're going to learn the average unit causal effects over a subset of the population, okay? So there's a trade-off that by using this different analysis, we're going to be able to get effects of actually getting Medicaid, but only for some people. We're going to talk about this method a lot more in detail later on. Third approach is to assume random compliance. That is, assume that people just randomly decide to take the drug or not when they're given the option, or assume that people randomly decide to enroll in Medicaid or not. If this is the case, then you can just drop non-compliers from your data and compare the average outcomes of people in your treatment group who actually enrolled in Medicaid with the average outcomes of people in your control group who didn't enroll in Medicaid because they weren't given the option. And that difference is going to give you the average treatment effect of having Medicaid on cholesterol or whatever. Okay? So unlike the instrumental variables analysis and intention to treat, we actually get the average treatment effect for the whole population. The downside here is that this result really depends on this very sketchy assumption of random compliance. It's just probably isn't true in most cases. People just make a decision of whether or not to enroll in Medicaid or whether or not to take some drug that they're in some clinical trial for. And that decision probably isn't random. It probably depends on things that are going to affect their outcomes, which we don't observe. Okay? And if that's the case, if random compliance is actually not true, and people are making purposeful decisions whether to enroll or not, then this comparison, where we just drop non-compliers, is not going to give us a causal effect. It's not going to give us the average treatment effect. The fourth and final approach for dealing with non-compliance is called bounds analysis. Now, the nice thing about bounds analysis is that it works with very weak assumptions. we don't have to assume random compliance. We don't have to redefine the treatment variable, okay, like an intention to treat analysis. And unlike our instrumental variables analysis, we're actually going to learn something about average treatment effects, the treatment effect over the whole population, okay? So it fixes those downsides of all those other approaches. The problem with it is that there's a cost of being so general. And the cost is we're not going to be able to learn exactly what the average treatment effect is. We're just going to get a bound for it. What that means is we're going to get a number where we say, well, the average treatment effect isn't larger than this. And we're going to get a lower bound which says, well, the average treatment effect is definitely larger than this. So in some cases, this is really helpful. If both the lower bound and the upper bound are positive numbers, then we know that the average treatment effect is positive, for example. Or if both are negative numbers, we know that the average treatment effect is negative. But if the bounds include 0 and have negative numbers and positive numbers, then we're not going to be able to learn the sign of the average treatment effect. Is having Medicaid good or bad for this outcome? We don't know. And that's because we're not making that many assumptions. Okay? If you wanted to make random compliance, then you'd be able to know average treatment effect exactly. So those are the trade-offs we face in doing this kind of analysis. And in the Oregon healthcare experiment, we'll go through each and every one of these methods to see what they give us.